let's say we have const user equal to name, Mike, age 30, location city, New York State. Now this is the user. Now when I say copy equal to user, it will not be copy, it will copy. This user is a object, so objects are of reference type. So when you assign a object or array to ref any variable, it will start referring to the original user, so where the memory is allocated for this object. So now both are equal, so this is not a copy. So when I say compare copy is equal to user, they will be true because they are referring to the same memory location. Copy one. You see, you get true as the result because they are referring to the same memory location. So how can you copy this object? So I want to modify. So whenever you want to do some operation, never modify the original array or original object, because you will lose the value and later you cannot get that original value. So whenever you do some operation, do on the copy of that object. So how can you create copy of that object? So you can create a new object. So whenever you create a new object, syntax, a new memory location will be allocated. So now I can copy whatever I have. So I can spread out the user object. Now what it will do? So if I just print this, copy one equal to user, you get what we are doing, compare. So compare is false because now this is a separate memory location allocated and this has a separate memory location because you have created a new object. So what is happening? You are copying all these properties. So you are using spread operator. So all of these will be spread out in a new object, but only the first level of the properties are spread out. So name and age will be spread out, and location. So location, what happens is location, and this is refers to the object. Now this object, as I said, whenever you create a new object, a new memory location is created. So this, what is happening is this will be copied as it is. So a new memory location will not be allocated for this. So whenever you create a new object, here location is a new object. So new memory location will be allocated for that. So now name is a Mike, age is whatever we have mentioned, and location does not contain the actual object. Location contains, because location is the object, so it contains memory address or reference of the object where that particular object is stored. So this is the object which is stored somewhere else and it contains 60,000. Now copy one, what you are doing, copy one, you are spreading out all the properties. So when you do spread operator, it does shallow copy. So only these particular properties will be copied. Now copy one will have another memory location with these particular object properties. So this, whenever you are doing spread operator, it just copies the memory reference. So it just contains that particular address. So this will have 70,000. Now it will have 70,000 address. So only the first level, name and age will be copied as it is. For location, as it's an object, only the reference will be copied. So it will still refer to the original location object. So this is the original location object. This copy one still refer. So what happens is, now if I do this and if I try to change, so let's say first print user. And now I will change here, I change copy one dot location dot city. Now here I will change copy one. So if, yeah, as you can see, I have changed only the copy one location dot city. but it changes the original user's location. Now I am printing user and copy one. So you can see this is the user, its city is changed to Albany. For this also it's changed to Albany. So whenever you are using spread operator, it only does shallow copy, which is means only the first level properties are copied. So this is the first level, and this contains an object. So object or array, if you have, their memory address will be copied. So location of this user, copy one, will still refers to the original location. It will not be new location. So when I create new object, it's a different object. But in this case, when you are using spread operator, it does not create different object. It will just copy the reference of that. So copy one location, it still refers to the original user location. So that's why you see the both of these are changed. So even if I change now location, this is user dot location. When I say this is the last statement executed, now I'm changing user dot location. So this is the user dot location. Now copy one and user will have the same London location. You can see. So when you are using spread operator, you need to remember this is shallow copy and not deep copy. So if you want to deep copy, like, so when I compare this user and copy one, you will always get different objects. So you get false because they are not different, but the values are actually not copied. They are copied as a shallow copy. So it's not, location still refers to the original object. So now I don't want to refer to the original object, because whenever you are want to change something, it's good to not change the original object or original array. Always create copy of that. So to create a copy, what you can do is spread operator does not work, because if you have nested property, it will copy that particular location as it is. So what you can do is you can use this deep clone method, clone deep method they have, or you can, if this object is not a bigger object, so what you can do is you can copy that manually. So now I will create a new location object and I will spread out all the properties. So it has two properties. So I will spread out location user dot location as it is. So now when you compare, they are still false because they are different, and this is not exact copy. So copy one and user both are now different objects. So when I say copy one dot location dot city, it is just this object. Now location, this location does not refer to this. So when I change this, let me comment this out. So when I say copy one dot location dot city, only this particular object is changed. Then user object will remain as it. So for user, you will say city and state New York. You can see its city and state is not changed. Only for copy one it's changed. So this is known as a deep copy. So you manually copy at each level, or you can use that clone deep method. So I can have this. So let me use lodash-cd and we don't have to go there. Now we have included lodash before our file. So now we can use lodash methods. So let me try by printing underscore to see if, yeah, it's there. So now what I can do is I can do clone deep. What was that? Deep clone or clone deep? Clone deep. Const copy clone underscore dot clone deep. It does deep level copy. So I will create user object. Not here. You can see you get exact copy of this particular user. So New York and state, and they are not equal. So when you compare them, they are having different memory address. So when I compare clone with user, you will get false because they are different. So clone deep creates a copy of that object, and it does not do the shallow copy. It does deep copy. This is known as deep copy. So you are having separate memory address, or everything is separate. You are not referring to the original object. So clone deep method, you can use Lodice method to create a deep copy, not the shallow copy. So there is this is using spread operator is a newer way, ES6 way. Before that, we were using object.assign method. So const copy clone one. So object.assign method, you can pass multiple values. You can see target and source. So here is the original target you want to pass, and you can pass multiple values. So let's say name Mike, age 40, clone one. So you can see now we have a new object with name and age property. So this first parameter is important. So if you don't pass this parameter, then the clone one, let me show you, const user one. Now what I am doing, object.assign first parameter is the user one, and then I am adding age of 50. So as I said, when you use spread operator, if you already have a same property, this property already exists, it will be overridden. So now you have name Mike and age 50. But this, when you don't pass this user one as the object, it changes the original object. So if I see this user one, you can see both of them are same. So this, if you see as assign method, this is the target. First is the target element. So it is the object to which these values will be copied. So if I have multiple values, I can do that also, and they will be copied or assigned to this user one. So if you don't want to modify the user one or original object, pass a new object. So when you create a new object, new memory location will be created. Now this result, so when you don't do this user one will have that modification, and that will be returned in clone one. So the reference of that will have, clone one will contain reference of user one. But when I say empty object, now we have another object, a new object to which these properties will be added. So you can see now what I'm printing, clone one. Clone one, age 50 is printed. So if I add age 60 or salary 50,000, those will be added here, age 60 and salary. So this is same as using spread operator, but spread operator is better than this. So if I want to do same thing using spread, what I can do is I can have this entire new object, then I will spread out user one properties, then I will add age 50 again. If I want to add age 60 and salary 50,000. Now this is a newer way, ES6 way. So you spread out these properties and add those properties. Instead of this was the original way. So you provide each object separately, and they will be combined into the one which you have passed as the first parameter. So this is the new parameter. So all these objects will be combined, merged into this particular target object. So if you don't pass this, so this will become user1 will become target object. Now user1 will have all these properties merged. So now both are same. Clone1 and user1 are same because you have modified user1. So always whenever you are using object.assign, make sure you are passing different object. So it will not override or it will not change the original user1. Now you can see both are different. So you have not changed user1. User1 still remains as it is, name and my age. Object.assign and spread operator both does shallow copy. They don't do the deep copy. So even though you are referring to user1, so here you have not added location here. So user1. So now if I say clone1, so clone1 contains user1 property. Instead of user1, if I do user, so what contains in user contains location. So now this clone1 will have this location object also, but it also does the shallow copy. It's not deep copy. So when I say clone1 dot location dot state, you can see state is changed to Albani. Now if I print this user, you can see both of these are changed. So user1 and clone1. So both are referring to the same location. So either you use spread operator or use object.assign, both are doing shallow clone. They are shallow copy. They are not doing deep copy. So if you want to do deep copy, you can use this manual spreading. So you need to spread each property manually, or you can use clone deep. This is deep copy. This is shallow copy. Not this one, this entire thing. So here this is not shallow copy because you are doing manual thing. But if I don't add this, then it will become a shallow copy because it will be copied. Only the first level properties are copied as it is. So now this is also shallow copy. So it is, so when you do shallow copy, only the first level are copied, and for object, so this contains object. So this clone one will contain still refers to the original user object location. So that's why when I changed clone one state, it changed the original user state also. So that's you need to remember. So this does the clone deep clone, you can manually do, or there is also structured clone. So JavaScript has added structured clone. So this is not too much supported, it's a recent addition that also does the deep clone method. So you can use structured clone method. So structured clone, now let's say user structured and user. Now you can see both of them are same, but they are cloned now. So it's a deep copy. So when I say structured dot location dot city, let me change it to London. Now you can see structured has city of London and user has city of New York, because user contains the original New York city. So this is the user whose city is already New York. So it is not changed. Only when I say structure.location.city equal to London, only the structured city will be changed. It will not change the user city because this is doing deep copy. So this structure will have separate location. So it's not reference. So it not refers to the original location. So this is known as the deep copy. So structured clone you can use, but that is not well supported. So if you see, can I use it's only 90% support. So not all browsers supports it, but it's a better way to use structured clone. Structured clone. So you can see structured clone API. This is the browser, Chrome browser, supported February 1 to 30 May. And you can see the total support. It's supported by 90% of browser. It's not 100% support. So Firefox, till these versions up to 93, they don't support it. So this is a very nice website. Can I use? You can check any CSS property or anything if it is supported or not. So if I say gap property, CSS gap property, whether it is supported or not, you can see it's 95% supported. Or if you want to use any flex property, display flex, you can see it's supported globally with 98%. So we always use CSS display flex property. So this here you can use, check what it does and how much support is there for any API. If you want to use, you can check it here. Caniuse.com. So this is deep copy. So you can also do deep copy using JSON.stringify. JSON.stringify user. So this is, you can see it's as it is, but it's now stringified. Now, if you want to get that value back, convert it. So when you use JSON.stringify, it converts into string. So if you want to get back the original object, you can use JSON.parse deep copy. Parsed. Now you can see you get this result back. So original object you get back. Now when I say parse, not parse, deep copy, location.city equal to USA. Now user contains New York property. So and this I am changing from deep copy only. So no, only the deep copy city will be changed to USA. Cannot set properties of undefined. Oh, this is not parsed. We should do this here because this deep copy is a string. Now this is actual object. We can see user state is Albany, what I'm changing city. City is still New York. For parsed, city is changed to USA. So only the parsed, whatever you have deep copied, that will have the city changed. So they are both different, they are not same. So this is also deep copy. So deep copy means everything is different, even objects are different. But this stringify method you should not use because it's a slower, and it if you have some, what you can say, functions or date, they will be skipped. So you will not get correct data back if you have some functions. So you might have functions here. So this object might contain display function. So if you stringify this object, then you will lose this context and everything from this display object. So you will not get that original object back. So if I add display here, function, display function, here I remove, yes. So this is the user object. Now if I see here, display function. Oh, structured clone also does not work with functions. So let me comment this out. So you can see original contains display function, but the parsed one does not have functions. So they are skipped when you are using JSON.stringify. So you should not use JSON.stringify. Structure clone also has the same issue. So functions are also skipped, but that is better than using JSON.stringify because it's very slow. JSON.stringify is slower. So the great way of doing deep copy is using clone deep. So this is a popular method. So if you don't have any large object, you can do it manually, which is better. But if you have a lot of properties, then it's better to go with deep clone deep method of Lodash. That is a lot faster and it works really well. So these are the different ways you can use what you can say, shallow copy and deep copy. And this is how you need to remember whenever you create new object, new memory location will be allocated. So when I create this object, new memory location is created. I have some, let's say I have user object, user array. Let's say this is object numbers. When I say numbers 10, 20, person, so this is an object and this contains a numbers property and I am assigning a new array. So when you create a new array syntax, its new memory location is allocated. So numbers does not contain the actual array. It contains a reference or address of that array where the actual array is stored. So this will have a separate memory location. So when you create something, it will have separate memory location. So when you declare array, that is a separate. So when you compare array or object, you will always get false as the result when they are separate. So I have this AR1, 10, 20, as I say, I think I have shown you. So when you are allocating different array, they are always different. So when I say AR1 equal to AR2, you get false because they are not same. Because AR1 contains the memory reference, memory location or reference of this particular array. And if I do US OB1 name Mike, OB2, so even though content is same, they are different. So you get false because they are different. But if I say OB3 equal to OB1 or OB2, and if I compare this OB3 with, now OB3 refers to the OB2. So when I compare them, OB3 and OB, this is not OBJ2, it's OB2, you will get true as the result because OB3 refers to OB2, and this is the actual object which is stored in the memory. So OB2 contains memory location of memory address of this particular object, and OB3 also contains that memory location of that particular, the same object. Now this OB3
is the solo copy only, right?
No, this is not copy. This is you are just referring.
Okay. Okay.
Copy means you create a new object and you spread out those properties. That is copy. So this is not a copy. This is just referring to the same location. So OB3 just refers to this OB2. So now OB3 equal to OB2 will return true, but this will be false. This will be OB1 because OB1 and OB2 are different objects. So they are stored separately in memory. You can see OB1 is true. Now, if I compare this OB3 with OB1, what would you get? So OB3 refers to OB2 and ob1 refers to another object. So both are different. So this will return false. So when you compare objects and array, separate objects and array, they are always different. So when I compare user one, so user dot location, if I compare with what we have, let's create location here. When I compare with ob2 dot location, they are totally different. So this is a string. Let me add city. This is the object now. So when you are comparing with string, they will be equal because the value is same. So if you are comparing with this, let's say I am comparing New York, and this also has location New York. So both are same. So when you compare with triple equal to, you will get true as the result. So this is user dot no, this is not user, it should be ob1 dot location, and I'm comparing ob2 dot location. So these are string, these are not reference type. So these are primitive type. Primitive types are not referred by the address or memory location. So they are compared with the actual value they are storing. So you get true because they are true. So even if I add Boolean values here, false, false, they will be compared because they are compared by value, not by reference. So you will get true. But when they are object, so when you create a new object symbol, it's a new memory location. So when I say city equal to New York, and this will have city New York only. So even though they are having same value, they are not same because this is on separate memory location. This is stored on separate memory location. So you will get false as the result. So you need to remember that when objects and arrays are compared, they are always false. So these are different things. But when you are assigning to the same memory location, referring to the same object, then at that time they will be equal. So ob3 is same as ob2. So when I compare ob3 with ob2, they are equal. So you get true. So ob2 is true. So any question in this? This is very important. So when you are using a React, you have a state. If state is larger, it contains a lot of data. So previously with class components, this clone dip was used a lot of time. But in when you are using functional component with hooks, it's not used much. But still, if you have some state which is storing some large object, in that case, you should not change the original state whenever you want to manipulate that state. So you always first need to create a copy of that and then update that particular state. So you always use clone deep method for doing that. So it's always good to not change the original object. If you want to change something, create copy of that and then change it. So that's always better. So you will have original value also. If you need sometimes later, you can refer to that. If you directly change on later, you don't have access to the original content. So that's why it's always better to not mutate the data. So that is known as mutation. Don't mutate the object or array. So keep it same as it is. If you want to change something, create a new object or array, like a copy of that, but don't use spread operator. Spread operator does shallow copy. An object dot assign, which was the old way, ES5 way of creating copy, that is also shallow copy. So if you want to do deep copy, if the object is smaller, you can do manual at one level. So if here I have name property, another object, so let's say name, hello, I want to copy here, deep copy. So this is deep copy. But now in the location, I'm spreading out these properties. So this now name, this name location dot name will refer to this particular. It will not be deep copy. So if I want deep copy, I will add that name property. So location contains city state name. City state will be copied. They are separate because they are strings. But this name is an object, so they will not be created again. So it will just, this name will still refers to the original name object. So to avoid that, you can create a new object and you spread out all the properties. So if you have multiple properties, that will be better to use spread operator. So what I can do is I can do user dot location dot name. So now you have another object. So this is an entirely new object. So it's not a copy of that. So this name will not refer to this. It's a separate object. So that is known as a deep copy. So that's it. Any question?